If I don't. We compare that as like how my bus splitting campus and policy J1. And I'm like, I feel that they seem that's like all many people. Yeah.
All right, it's 5 o'clock, guys. That's 5. So let's get started. We're currently on week 4, okay, of the semester. So just FYI. So today we're going to begin our topics. All right, so let's start with bright space. So far we've covered all right, so far we've covered machine learning word problems, and you did have a homework assignment for that. You've submitted that, hopefully. Then hopefully you're going through these tensor operations. I haven't given you the homework yet for this. I'm going to continue doing some problems of these during every lecture. It's my plan. So every time we meet, I'll try to do a few, and then I'll give you some problems. Okay, so I think that's probably a little bit better approach. So we'll, I plan to get to some of these today, but today we're going to get to this module that you see here, your first neural networks. Okay, so I'm going to go over that, and that should lay the, the foundation for everything else that's going to come. Remember, this class is mainly focused on neural networks. Okay, so that's going to be what we're going to cover today. We're going to start at the beginning, and it's going to include some coding, and you have a lot of reading to do that you should do sort of on your own, okay? But I'll go over the code today, and I'll talk about that. All right, so I have here, so before, I'm going to, I guess, let everyone come in, and while they're coming in, I wanted to show you something. So I don't know if you guys keep up with the latest developments in AI. So it's a very rapid and it moves really quickly. So this is called diffusion models or real-time game engines. This is a paper that I just became aware of about 2 weeks ago. It's very recent research, like very recent, last few days or a few weeks. This was done by Google and I think the Tel Aviv University. And it's just a little nuts. This is something, that really impressed me. It's not a new methodology, actually, which is really interesting, right? So it's not a new algorithm. It's really just a combination of algorithms. It actually combines like 3 fields amazingly. So I don't know, you guys probably like video games, I assume. I don't know if you guys have ever played Doom. I know that this is what I played during my time. And I had this on a computer and I liked it a lot. So this game in the 90s or so, whenever it was made, I don't know if you've ever thought about how a game is developed, but you write a lot of code. You got to create a game engine. You got to create all this. It's like a whole profession, right? That you have to have. It's very labor intensive. I don't know if you would believe me when I say that this game that you see here was generated entirely by a neural network. There was no code that went into this except the code that goes into creating a neural network. But there was no actual game engine, game development. No one created, new graphics. Obviously, it uses images from a train set. But so you might say, okay, you need to create a game to then train a model. Well, actually, what I would argue is that games in the future are going to look like real life. Because you can imagine how Tesla, for instance, right now, as you're driving those Teslas, they're recording everything, everything they see with cameras and things. So they really have everything that they need to create a game. So imagine now, if you want to do a car related game, the images that you're going to see are basically very photorealistic, right? It's going to be what, that's the information. So this is pretty amazing. It uses stable diffusion, and it uses reinforcement learning, which is one of the tools that has been used extensively for games. And they basically combine those tools. Now, this is also not just a video or a movie. This is literally an interactive game. So it's a game that you can actually play with, right? So this is it wouldn't be amazing. It would just be Sora or something else if it was just a video or a movie. But this is not it. This is an actual game that you can play with. Because imagine you have a controller like a joystick, you're playing through reinforcement learning, and those actions and states are being recorded. But at the same time, you're saving the images, right, of the game. So eventually you train a neural network with both the actions, the states, and the images, and then the neural network is able to capture everything. So that now you can run it in real time, give it commands, it's going to take those commands, tell you something about the state of the game, and also render what you're seeing here. So you can literally create games. So this is really nice. I really like this idea. I'm sure it took, I was reading the paper, it took several GPUs, multiple GPUs, but I'm sure eventually they'll do pre-trained models that you guys can fine tune. And I think very soon, you guys will be able to take tools like this to create your own games. So, it's a very, and I think the applications of this are beyond that, right? Because you can simulate lots of things for education, for training, for lots of things. So definitely pretty impressive. So I wanted to point this out because it's really fun. But any questions on this? So it's definitely a really fast moving environment. This uses neural networks, which are pretty complex. Towards the end of the semester, I do plan to cover LLMs, which this does not use, and stable diffusion to some extent. So hopefully we'll get to see at least a very simple code of how this works. Does that make sense? But for you to get to that level, we got to start at the beginning, right? So that's what I'm going to start today. I'm going to go over the basics of PyTorch, creating a few neural networks. And then just keep in mind, it just gets more and more and more and more and more and more, right? Until you arrive at these. The state of the art today are either stable diffusion models or large language models like GPTs and things like that. Okay. But yeah, I'm not saying this has to be your project, but definitely gives you the motivation, because unlike a Chat GPT or something like that, which I don't think, you guys can't really make a Chat GPT because OpenAI will always be better than you. You can make something like this, because it's just your creativity, right? So imagine all of you creating your own games. Eventually, one of you will create a really nice game that people actually like. So it's more about, this gives you more, I think this is more for the masses, if you will, than say something like a Chat GPT or something like that. But anyway, I wanted to point this out. This is a very nice paper. We might come to it towards the end of the semester. This is, to me, the state of the art right now. I haven't seen anything that is more impressive than this. So, currently. All right. So anyway, so I wanted to start with that. And I think that, hopefully we're recording. All right. So today, we've done word problems and we've done tensor operations. I'll continue doing that. Like I said, I have about 109 tensor operations that I think are fundamental to deep learning. We've done about 12, I think. So I'll just keep going with those throughout the semester. But today I wanted to get started with neural networks. So we're going to start here. Your first neural networks is this module. I think it's pretty simple. I wanted to keep things more like constrained. So I just have 2 links. Okay. So let's look at the first link. All right. So this is my blog on GitHub, basically, and it's all the material. So read this. That's all I can tell you. Read this. All right. Most of what I'm going to do today is this chapter 4, deep learning, starting at the beginning. So that's basically the code that I will describe. But if you want a little bit more description, read through that. You don't have to read chapters 1, 2, and 3, although if you have time, read them. Okay. They're more basic things, so you can take a look. I wrote this, so I may have spelling errors and things like that. I don't, I'm a one-person operation, so I can't really polish all this stuff. But anyway, yeah, definitely chapter 4. I'm following literally what I have there. So I've tried to create this material and make it available to you guys, so you can just read through it. So it'll go over basically everything that you need, like the libraries. So things to know about the code, right? And I have the code in there. I have some graphs that you can read through and the meaning of neural networks, getting started with deep learning definition, some PyTorch basics, loading the data. So I'll demo all of this today as we start going over the data sets, but this just provides more descriptions and things like that. So definitely read through this. We're gonna go over regression models today. And so this starts with linear regression, and then it gets into actual regression models. And then we're gonna look at something called the wine quality data and Iris. I think those are the two easiest data sets. I like playing with the wine quality data set because I can transition from regression to classification really easily with this data set. So it allows me to show you that there's only a slight difference. Okay. So these are the topics that we're going to cover. Confusion matrices and things like that. I'll cover that as well. So everything should be here. How to create, we're going to do this today, how to create neural networks. Okay, so I'll go over that. How to run, how to measure performance, some of the metrics that we use, the results that you should be getting, right? How to create some of these graphs. And then it gets into a little bit of the background between regression and what is classification. So as I said, we used a wine quality data set for both. So we'll cover that. And then how to read the data, what are, some of the terminology. I do provide some theory and intuition of logistic regression. So I'll come back to that, but definitely, read through it, please. Okay. Some graphs there. The networks, what is cross entropy, binary cross entropy, multi-class cross entropy, as we start to transition from regression to classification. I'll start with regression because it's the simplest concept, right? As far as the theory, although the first neural network may be like the Iris data set or something, because it's just a very tiny data set. And then the wine quality data set, and then once you finish this chapter, you should understand what deep learning is. Okay, so it's basically that straightforward. And then after that, we can start making our networks deeper, more complex, advancing to things like CNNs and autoencoders. Okay, and what they are. All right. So basically, this is the code, Iris, which is what I'll start with today. And then you can see that's all described in this here, this text. And then after that, more challenging deep learning with the wine quality data set. So we'll go over that as well. Okay. Yeah, and that should be it. All right. So this is definitely your assignment. Make sure you read through this material. And if you have any questions, let me know. And then I'm just going to jump into the code. Okay. Does that make sense? All right. So that's the plan. The best way to learn this is to build a neural network. Okay. So we're going to build a neural network. Yeah. And then just the beauty about neural nets is that you build something and then you just add a thing and then another thing. You keep adding to them until they become something like stable diffusion, which is massive. or like a transformer, which is massive, but really it's all coming from the same ideas. There's architecture, loss functions, and data. It's like those are the three things going on. Okay. Any questions? All right. So I've given you the material that you need to read. And then also, let's go back to the table of contents and on Brightspace. And then the other thing I provided is this link. This is the code. So I've given you the code already. You know, it's on the GitHub. So you just follow that link. And it's basically under second edition. You can see chapter 4. So these are the scripts that I'm going to be working through today. Okay. There's 2 data sets that we're going to need. The wine quality data set and the iris data set. And these are basically the 3 scripts that I have. So as you can see, I have basically a regression and then 2 classification scripts. Okay. So we're going to do this. So what is classification versus regression? So there are differences in the code, obviously, but in essence, these are models where regression, you predict a real valued number like temperature, 32, 56, 78, right? And in classification, you predict, okay, this is a type of flower, iris flower. So this is Setosa, Virginica, or versicolor, for instance. Or this is a cat or a dog, something like that. So that is basically the difference, okay? Any questions? All right, so this is what we are going to do. So I'm going to start, as I said, I've assigned basically the material in these 2 links. Okay, and then we're just going to go through, start creating these networks. Okay, for you to understand something complex like, you know, a GPT, definitely you have to start with something much more basic. Now, don't fall behind, because if you fall behind on something, you're really going to not understand other things, right? So it's like you have to think of it as the tensor operations plus simple networks, you know, go together to become more and more complex. Okay. All right. So the next thing I'm going to do now is I'm just going to start my the Anaconda prompt. Go here. Anaconda prompt. And we're just going to start building this from scratch. And yeah. Okay, so ITS 520, there it is. All right, so we've done some, have a Jupyter notebook in there where we started. Hopefully you practice those problems that I mentioned and, you know, developing some muscle memory, getting used to the environment. You know, as you know, those are essential operations. So now I'm gonna do Conda environment list. Okay, so ML 2020. Yeah, so it's probably ML 2024. So Conda activate. Pi 38. Okay. So remember, we are now in the environment. You can see that there, right? Right there. Okay, now we are going to create a new Jupyter notebook, and this is going to be for our first problem. Okay. All right, so in the interest of time, I'm not going to type all of this, right? So I'm just going to download the scripts and kind of go through them, and you can follow along and do the same. Okay, please stop me if I'll try to go not too fast. Okay, so how do we do this? We need to go to the links that I provided, right? So not this one, because this is just like the description of things for your own reading, but you go here, right, guys? So any questions? All right, so this is basically the GitHub repo. You can download the whole thing if you'd like. I'm just going to download the data right now. So I'm going to go to Iris CSV, which is the one I'm going to do. You can see it there. So I'll describe what this is. All right, you can just click on download raw file. So that should have downloaded. Gone to my downloads. Then I'm going to go to, you can see I have it labeled as Iris and then classification. I'm assuming this is Iris or the wine quality, sorry. Yeah, this is wine quality. So Iris should be this one. So I'm going to click on that. And I'm going to download the Jupyter. Okay, so I have both things downloaded now, right? Everyone with me? So you can just now copy these to the folder that you're working on. So I'm going to go ahead to the downloads folder. Go to downloads. Okay, so this one and Iris. I'll copy. And I'm going to go to the desktop. And it should be 5/20 fall 2024. There we are. Right, there we are. So you downloaded the Jupyter notebook. Now let's go to the terminal. And if we do dir here, we should have both that Jupyter notebook, classification, deep learning, algorithms, PyTorch, Iris. Okay. And then the Iris CSV. Okay. So now we already initialized the environment. So I'm just going to do Jupyter notebook. And it should begin. And then I'm just going to go over the code, okay? Now, the way that I write these scripts, I try to create them as kind of a template so that they're always consistent. So you'll kind of see that. All right, so this is the data, iris. So the iris is a flower, right? It's a flower, it's like a purplish flower. It's like very famous flower in machine learning. And there's basically 3 classes that you have of this flower. So I had already opened, I think. Let's go here because it looked nice. So I'm going to open Iris CSV. Okay, so this is the first data set pretty much that everyone starts with, Iris, and then MNIST when we get to images and things like that. So you have to you know how we were doing X and Y, right? And we looked at problems and they have rows and columns. So you can start to see that here. Iris will have 150. It's got 151 because of the labels at the top, but it's got 150 samples, 4 columns, and then the class. Okay. And if you notice, the class is currently a word. This needs to be converted into a number. We will do that as we start going over the code. So sepal length, sepal width, petal length, and petal width are basically these measurements that you take on the flowers, okay? And based on these 4 measurements for every flower, you know, you can imagine that some flowers that are smaller might be setosa, and then other flowers that are a little bit bigger could be versicolor, and so on. Okay. So the assumption here is not an image of the flower, but just measurements. Like if you took a ruler or something and you measured it. Okay. So that's the basic idea. All right, this is just a .csv file. I encourage you to download it, take a look at it like in Notepad. You'll see it's just comma separated. This is a good data format for data sets. Okay, make sense? Everyone with me? All right, so now that we looked at the data set, let's take a look at our Jupyter Notebook. All right, so classification here. And I'm going to go over this script. Okay. So you can see I've already ran the Jupyter, and then this is just basically my pipeline that I always follow when I'm training neural networks. Okay, so some kind of an example. So, you know, we use Python, but as you know, Python uses a lot of libraries, right? So that's one of the powers of Python. And so we've already did a few examples of NumPy. We're going to use, of course, Torch. This import Torch is the main library, okay? And then you'll see me use things like pandas and sklearn just to provide some help with pre-processing, or, you know, sklearn has some nice metrics that we might want to use, okay? Then as far as building our neural networks, these 3 lines of code are going to do all the heavy lifting, basically, okay? So from Torch, we're going to invoke torch.nn. That NN means neural network. That's going to give us a lot of the primitives that we need to build our neural networks. From torch and then functional as F, that's going to give us some of the loss functions and things like that. And we're going to look at something called the optimizer, which is basically the tool that we can use to train our models, okay? There's a lot of background that goes into these things. What I suggest is read my notes, right? Because that digs deep into that. But instead of giving you a lot of theory and then getting to the code at the end of the semester, I'd rather do this, okay? So I think this motivates your mind a little bit. So you start asking questions like, what does optim actually do? You know what I mean? And you'll understand things a little bit better that way. All right. So anyway, the first line of code. So I'm actually going to start running this. So I have the file. You can rename it if you want. You can always just get it again from the GitHub, and you know, if you make a mistake. I usually hit the kernel and then I clear all the outputs and restart the kernel basically. And that's just, I like to clean up everything, right? Just in case. You can see everything went away now. And so we're going to rerun everything cell by cell. All right, so I'm going to start here. So when you run this on your environment, actually, I created a new environment myself. So that means that I may need to install some of these libraries. I think in particular, ML Extend, I think I'm using that one. So I'll probably need to install it at some point. I'll leave it off for now just so that you can see the effect, all right, that it breaks. But I think everything else we may have. Let's see. And if not, we install it from the Jupyter just by doing !pip install. So let's go ahead and get started. Okay. So calling some of the libraries, NumPy, Torch. Let's give it a minute. Okay, so see, it doesn't have pandas. So then we're going to have to install it. So pip install pandas. Hit run. So you only have to do this one time on your environment. So that should be a good thing. think it's doing it. Okay, so it gives us some output. We look at it, says that everything worked. So then you can comment it out and go to the next one. So I'm going to hit run, see if it breaks on something else. Okay, so sklearn is not there. So then pip install. And I think this one is scikit learn. Okay, learn. Let's run that one. Any questions so far? Okay, so that it did this. All right, it's successfully installed, so that's a good sign. Comment it out. Hit run. See what else? sklearn. Okay, so it went through, right? So you can see the dot goes to a white background and no error. So that tells you that we've got PyTorch. So hopefully if you're doing this, you got PyTorch going now. Matplotlib is for plotting. You'll see me plot. Plotting is really important to view your data. You know, if you're doing data science project, people want to see plots and things. Okay, I'm pretty sure ML extends, which you see I'm using here, will break. So I'm going to hit run. Right. So, oh, matplotlib is not there either. Okay, so pip install matplotlib. Hit run. Okay, there we are. Look at it, successful. Okay, no errors. As you can see, this is how you approach these problems. Okay, hit run. And MLX10, yeah, that's the final one. So let's do that here. And hopefully that should be it. After that, we can just proceed. Okay, that was quick, successful, great. Comment it out. I usually leave these, as you can see, it's helpful to have these commands for future use. All right, so hit run. We load that cell, we load this cell. Okay, great. You can see the white dot here and no errors. We're not going to use XGBoost. So this is just a tool, a non-neural network-based tool. Very useful in like tabular data, like regression type data, but I'm not going to be using that. All right, I'm going to hit run. I have sklearn metrics. So this is something, we do have an actual lecture for these metrics. So in machine learning, if you remember in the pipeline, whenever we train a model, we need to measure performance, right? And that's going to be one of the things that we will cover a little later, but we're going to motivate that today. You'll basically start using it today, hopefully, if you're following along. So no errors there, as you can see, and it loaded. Onyx runtime, all these tools. This is for deploying models. So this is a topic we might cover later on in the semester as time permits. All right, but we don't need that right now. So I'm going to hit run so that you can see that was a comment, basically the 3 single quotes commented out. All right, so now we are ready to start training a neural network to predict if a flower is setosa, virginica, or versicolor, given 4 measurements that these things called features, right? All right, so there's a lot of terminology. This is the first lecture, and there's a lot of new things. I've described them in the link that I provided. Read that, and otherwise, I'll try to describe them as best as I can right now. They have deeper meanings sometimes, so we got to dig deep into some of these. Some are very easy to understand, some a little bit harder. But one nice thing about all of this is that it repeats a lot. So by the middle of the semester and the end of the semester, we're still going to be using these things, right? We're still going to be running number of epochs. We're still going to be running batch size. So you should be very clear as to what that means. You know what I mean? So that's one nice thing about this course is that, we're just always doing the same thing, just a little bit more complex every time with something new that we've added. So it's like a car and we added a turbo and then, you know what I mean? Or we add a spoiler or something like that. All right. So it's kind of like that. All right. So I like to follow, this is just my preference, like a template approach. So I put the parameters at the top, right? And then I start reading in the data. I always look at the data. I print the size and things like that of the data, right? Sometimes I like to print histograms of the data just to get a feel for some issues. Then we have to start converting the data into the constructs of PyTorch, which is something that we will do, like the data loaders, etc. We'll talk about what that is, and I'll try to motivate why that's useful. And then we get into creating the network architecture and finally the training loop, right? Once the training loop is done, our model we can use it, we can test it on things, and so on. All right, so I'm going to save the file. I'm going to hit run parameters, run that, no errors. So I created these 4 variables. As you can see, one is called the batch size, and it says 16. So in deep learning in particular, you always want to take advantage of the GPU. That's one of the reasons. So instead of always giving the GPU just one sample, you always give it more than one sample at a time because they can do things in parallel, right? So then you give it 16 or 32 or 64 samples at a time. That is, I give it 32 samples to look at and train on. In this case, I'm saying that I'm going to give it 16. Okay, this is also helpful because the neural network can look at 16 things at the same time and adjust the weights accordingly. So that can be helpful as well. The next parameter is the learning rate. This is a parameter that you sometimes have to play with. In general, the intuition is this is how much you adjust something. All right, it's like a type of a thing where there's quite a bit of theory that goes into this, and we will have to do a lecture just on this topic, which has to do with optimization. But in essence, it's basically a parameter that determines how big a change is going to be. So every time you're training your model, every iteration, you're adjusting values by a certain amount. And you can control how much you adjust them by this value. So in general, 0.001 is kind of like the default value used by a lot of the optimizers by default. But you can specify this. It can also be a variable learning rate where it starts with one value and then it changes, right? So Just keep in mind, it's usually a very small value like 0.001 or 0.003 in this example. We will look back to this later on. N epochs basically means how many times you're going to run the loop, okay? And what that means is how many times you're going to train your model given the data, right? So you actually grab all the data, right? So you don't, you know, this is something that I always say this because, you know, some time ago, this was a concept that was very strange to me, right? You know, why N epochs, right? Because we have a whole data set and we grab batches of the data set, right? And we give those those batches of the data set to the model. And then we do it once, and I thought, okay, that's it. But then I started to look at N epochs, and it basically N epochs, the interpretation was that I was taking all that data, and I was giving all that data to the model instead of one time, in this case, 4,000 times. So it's like, you know, the model needs to look at the data 4,000 times, the same data 4,000 times. It almost felt to me like it was cheating or something. But I mean, that's how neural networks learn, all right? So they need to look at what you do usually is that you randomize the data every epoch, right? And you'll see how we can do that. And that just helps the models to learn better, okay? And then you give it all the data, you know, 4,000 times. Okay, that's necessary. So to give you an example, you know, kids, when they're learning, you know, if there's a wire there and they walk and they trip on it, that's it, you know. They don't need to trip on it 4,000 times to learn. Don't be careful with the wire. But a neural network in this analogy would need to trip 4,000 times. Do you guys see that? To finally start to understand that that's a problem. Got it? So that's, you know, a good intuition, I think. All right, this other parameter, epsilon, this is something that I use for division, right? So for you know, when you're dividing by 0, sometimes it could give you not a number. So by adding that little epsilon, then you can avoid that problem. Okay. All right. Any questions? So a lot of concepts there, by the way. You know, that's a lot of information, but these are parameters that you will be using all the time. And actually, some of them, and they're all really important, actually, in particular, the learning rate. Okay. All right. The next step is we're going to read in the data. All right. So in this case, you can see that I have my iris.csv. I downloaded that file. It's next to the Jupyter notebook here, right? So here's my Jupyter, and here they're in the same folder. So I don't need to specify any paths. And I'm going to use the standard technique nowadays is to use pandas. Pandas is a very versatile library. For those of you that have taken like SQL or something, it has some of that functionality, which is really nice. It also allows you to format the data more nicely. It allows you to have the headers and things in a better way. I'm going to basically tell it that my file is at iris CSV. I'm going to use the pandas library here. Read CSV. I'm going to tell it that the delimiter is there's a comma separated file, and I'm going to load everything into iris raw data. So this starts to get into that whole idea with the word problems of your X and your Y, if you remember, right? So currently it's like we're reading the whole X and Y together, okay? You know, and then we're going to have to split it up into X and Y as we did in the word problems. So I'm going to go ahead and hit that. And then usually my practice is I like to look at things. So at this point, I will run what I just read, and I will start to check things in the model. So as you can see, currently, also pandas, you know, can do strings. So we have here species is the class. This is going to be, as I said, a classification problem. It says that it goes from 0 to 149. So we have 150 rows and 5 columns. We've got 4 features and the class that we're predicting. So I've got my data there. Now, the next step that I'm going to do is I'm going to use a very nice feature within pandas, because this is now what is called a pandas data frame. So I'm using the pandas, and there's many ways of doing these things, but this is one way that I like to do this. I'm just using the pandas map function, so I can exchange the words setosa, virginica, and versicolor with numbers. Neural networks don't like words. You know, if you think of GP, you know, even Chat GPT and things like that, everything in that GPT is numbers. So you got to go from, you know, 200,000 syllables or you know, words or whatever you want to think of, and you got to convert that into numbers, numerical representations. Okay, so everything needs to be a number. Obviously, this is a lot easier than creating the vocabulary for Chat GPT, for instance. Right? Much more difficult. But anyway, we're starting here, so we can use this function. So in essence, these classes should now be numbers. Does that make sense, guys? Any questions there? So the classes will be 0, 1, and 2. So I'm going to hit run. And there you go. As you can see now, the data frame looks exactly the same, but this column, instead of being words, it is now numbers. Okay? All right, perfect. All right, now that I've done that, I'm going to print out the headers list. And this is something that I like to do. You know, this is data science, if you will, just looking at some of the statistics of the data set that we're looking at. So we know that we have sepal length, sepal width, petal length, petal width, and species. And we want to create a correlation matrix. And a correlation matrix is a useful piece of information because it can tell you relationships between variables, right? So this is something that you can take a look at. You can see that there. So there it is. All right. So I'm going to move this over here. So it's a nice tool I like to use. You can see it's just 3 lines of code. We take the pandas data frame, we run it through a NumPy correlation coefficient function, which gives us CM. Then we run it for presentation through this heat map, and then we just plot it basically. Okay. So that gives you the relationship in particular between species and all the other variables such as sepal length, sepal width, right? So, you know, for instance, if this value is 0, it's basically telling you that that feature is not useful for the prediction, right? But if the values are not 0, whether they're positive or negative, then it's telling you, okay, these features are good for my prediction. Does that make sense, guys? So you can see that here. That looks like a 1, yellow 1. So you can look at the graph here, right? Positively correlated. So basically, that seems to be probably the best one, right? And this is a minus 61.65. And so, oh, that's species, obviously. Sorry, I missed that. So obviously it's 1 because it's species to species, but these 4 are the X features to predict the class. Got it? So in that case, then one of them is negatively correlated, and this one is the positively correlated one. So I guess if I had to pick one, maybe I would start with petal length and so on. Like if another thing to consider is that collecting these could be very expensive. Like what if you had to hire people to go in a forest and measure these things? You know, that's very expensive to do, right? So, you know, so maybe you could use that information accordingly. In any case, this is something useful that really quickly gives you a little bit of data science of your data set and what's going on, your features, etc. Any questions? Making sense? Yeah, please.
I mean, these are all linear correlations, right? I mean,
I'm just
this is sort of a limitation like of this map. Like these are linear correlations. So for example, a function like y is equal to x squared, even though y is correlated with x, the correlation would be 0. So
I mean, it's something I always use, and you know, it just gives me insight into which variable might be more. It doesn't have a neural network in there, if that's what you're getting at. So this is just some other methodology underlying, which I'm not sure which algorithm it's using. Yeah. So, you know, it's just a very simple thing to look at relationships, and, you know, it's one of the methodologies that you can use. But yeah, we haven't done anything with neural nets yet. Okay, so so that's that tool. The other thing I like to do is a histogram. So we'll take a look at that in a sec. So one thing that happens a lot with neural networks is that you're going to be moving around, right? So I read the data as a pandas data frame. I'm gonna possibly convert it to a NumPy array. And then eventually I definitely have to convert everything to PyTorch. So one thing that can't happen once you get into PyTorch is you can't annex NumPy arrays or things like that, right? So everything needs to be in the format of pandas. Okay, so I'm gonna go ahead and, as you can see with this function, iris raw data, I'm gonna convert it to a NumPy array. Okay, and I'm gonna print it. You can see it looks a little bit different now. So these are things that, you know, I do them, I guess. Now, one thing I can say is that, you know, a lot of functions that exist in NumPy also exist in PyTorch. Sometimes I just remember the NumPy version, and so I do it in NumPy. But I guess you could always choose other, you know, a function in PyTorch or a function in NumPy. So as you can see here, I've converted it to NumPy. I'm printing the shape. So this is 150 by 5. Okay, remember that I have my X and my Y here. All right, so the next step is basically to do that, right? So if you guys remember, in the word problems, we kind of got to the point where you always wanted to have that X and that Y, right, as a guiding principle. That's what I'm going to do here. If you look, if you've never done slicing, for instance, this might look very strange to you right now, right? That's why I gave you those 109 basic operations of deep learning. So in there were some indexing operations, some slicing operations. You need to really understand how to do that, right? So go through those problems, repeat them multiple times. So this is why I give you those problems, right? So this is an example of how operations are needed as we start writing our code. So this is slicing. So it's something that hopefully once we finish the script, I will try to get to in the 109, but you should also do this on your own if you can. So what I'm gonna do here is I'm going to take the NumPy array and I'm going to break it up, right? So currently it's 150 by 5, and I wanna break it into what? X of size 150 by 4 and Y of size 150 by 1. Do you guys see that? Just like we did in the word problem. So here, slicing, basically, you can see that we have an array, right, of 150 by 5. So the comma indicates the rows. Everything to the left of the comma is the rows. Everything to the right of the comma is the columns. So the colon here means all, basically, okay? You gotta like practice that and be clear. So 150, and then I'm saying, I'm putting a range here, and I'm saying, since I don't provide a value, that means from the beginning until the last one. So excluding the last one, basically. Yeah. So this will grab, this should grab 1, 2, 3, 4, but not the last column, right? Because we want to save that for the Y's. Does that make sense, guys? All right. So you should always like run these and run a little example just to confirm that the results are as you think they should be. For the Y, we do the same. From the same NumPy array, we grab all. Okay, so we grab all here. And then we grab from 4 to 5, all right? And that just means we grab the last one. Okay, there's different ways of doing this. So you just have to master slicing, basically. That's all I can tell you. Do all the problems I provided in the linear algebra problems, you know, and try to understand that concept. But this is slicing. So I'm going to go ahead and hit run. And now I can print. So here I'll add a new cell. So I want to print x.shape. And this is basically one of the most critical things when you're building neural networks, right? Always print these shapes. You'll see how they're very useful, right? So 150 by 4, that means the x, right? We've grabbed the first 4 features for all rows. And then now I'm gonna do y dot shape. And that should be what? 150 by 1. There it is. Because we've grabbed the columns at the end. Is that clear for everyone? Okay. All right. If you want to change the data type of y, you can. So you can see there as type int. Remember, these are NumPy arrays currently. And then there's the values as you have them. Any questions, guys? So at this point, you have your x and y. This is a direct connection to the word problems, because in the word problems, you were trying to figure out how to get that x and y on paper. Here, x and y in code. Got it? Pretty important as far as the template. All right, obviously this is data sets that are, you know, for academic purposes, for teaching. In fact, creating these data sets can be pretty challenging. Okay, this is hard things, definitely. And a lot of your work when you have a project is gonna be the data set and getting it in the right. And sometimes that's not gonna be trivial. Okay, you know where you need to get to, but how to get there will be challenging sometimes. All right. Now I like to print the histogram, and I'll tell you why. Okay. So the first thing is I'm going to look at the set of values, because here it's pretty obvious. It's 0, 1, and 2. But in other cases, you know, it may not be so obvious. Like I had the wine quality, right? I assume it goes from 0 to 10 because it says it goes from 0 to 10. But when I actually looked at it, it wasn't like that, right? So you want to basically figure out those values. So I'm looking here at y. Remember, those are the classes, 0, 1, and 2. Setosa, Virginica, versicolor. Okay, so the set is 3. So we have 3 classes. Okay, good confirmation. Then I'm going to use PLT. PLT is calling matplotlib, and I'm basically doing a histogram. I'm going to start plotting. Now, this course, I don't really cover all these techniques of plotting, okay? If we do have a course in visualization, so if you guys are interested in that, talk to Professor Gurjin. I forget the number, but that's a whole class on plotting and things like that. All right, so here I only use a few functions of matplotlib, so I think these are things that are pretty repetitive. All right, so you can see here I'm taking the y, I'm creating automatically bins, and I want it to plot a histogram of this data. All right, I'm going to give it a title like histogram with auto bins for the Iris data set, and I'm just going to show it. All right, and there it is. That's my histogram. So just basically, what does a histogram tell you? So you probably learned in your statistics class, right? It gives you the frequency of some value. And you might say, this is not important. This is actually really important, okay? This is going to affect your machine learning results. You can see that this is a very academic data set. Why? Because we have 3 classes, 0, 1, and 2, and each class has the same number of samples. We've got 50 samples of 0, 50 samples of 1, 50 samples of 2. That's really nice. That's machine learning loves that, right? Because what machine learning does is it looks at the differences of things. That's what machine learning does, okay? It's a machine of looking at contrast between this and that. What are the differences? So obviously, because it has an equal amount of samples of each, it can pay attention to every single one evenly, if you will, like fairly. But in more realistic data, you know, the data will not look like this. Instead, what you're going to have is what is called a class imbalance, where you might have, you think of the scenario of fraud in a bank, right? That's an example I always use. Most transactions in a bank are probably not fraud, hopefully, right? And then 2% or 1%, probably less than 1%, are going to be actual fraud. But if you're trying to build a classifier that detects fraud and not fraud, those two classes, what's going to happen is you're going to end up with one column that's really high and then one that's very small, right? So that's class imbalance. In this case, by looking at this, I already kind of know, okay, this model could be a good one. Does that make sense, guys? And then dealing, ideally creating a model. So to train a model, you probably want your data to be more balanced. So there's many techniques that go into that and so on. But for now, all I'm giving you is that you can calculate if something is balanced or imbalanced. Does that make sense? Any questions on that idea? We'll see it actually when we look at the wine quality data set. It should be not as perfect as this. So the wine quality, one reason why I like to use it is it's a little bit, less simple, right, to process. All right, so now I'm going to proceed. So notice I'm saving constantly. I'm going to proceed and just printing the shapes. I like to print shapes. All right, now what I'm going to do is that the next part of this process is to split the data. All right, so whenever you train models in machine learning, right, you're going to have a data set of some kind, but you have to measure performance. What that means is you have to train a model, right, with some data, and then you have to evaluate that model, right? So you can't evaluate it on the same data that it looked at when it trained. That's kind of like cheating. So the best example I can give you is, let's say that I do a competition, right? And I'm going to give $1 million to whoever wins, gets the highest score. So you're all very motivated to do that, right? And you're going to do whatever it takes to win that competition. So I have to be fair, I'll give you a data set to all of you, and you all train on that data set. You're going to train your models, and then when your models are trained, I'm going to give you another data set, a test data set, and then you all run your model on that data set, and whoever gets the highest score wins. You see that? So you're going to hold out a data set, basically, right? But what if you could look at this data set that I kept somehow hidden? Then you could do tricks on your model to make it better, right? And so that, that's cheating, basically. So whenever we do machine learning, we have to, to measure performance, we have to split the data into train and test set. All right, this line of code here is basically the random seed. Notice that I'm adding it here. I do this, I call this a poor person's cross-validation. And the reason is that I'm trying different splits of the data, running it multiple times. And because I'm trying different splits, every now and then the results might be a little bit different, but there's a trend that's going to emerge, right? I'm going to see that the scores are good or bad. And so I like to do this. You can also hard code a number, and the only difference there is it's always going to be the same split. So the score is always going to be pretty similar, right? So anyway, so now notice that to split the data, I'm going to use train test split. This function, if you look to the very top, it's coming from sklearn. So when I imported the libraries from sklearn, I am importing train test split. It's just a function I like to use. It works nicely, so why not? And there are other functions. That's one thing in like this field. There's always a function in Torch. There's always a function in whatever. So, but this is kind of my pipeline. All right, so notice that what you do is we already created X and Y, right? We already have that. You guys have done the word problems. You know what this data is, very important. And now from that X and Y, I'm going to split it based on this. So this is test size 0.20. So what that means is that 20% of the samples are going to be used for tests. We're going to hold that out. And then 80% of the samples are going to be used for training. So how many samples will be in train then? How many? Out of 150? 120. And then how many samples will be in the test set then? 30, exactly. All right, so you need to be very precise in these numbers, right? Whenever you're doing your machine learning, these are numbers that you should know, okay? All right, yeah, and then if you notice, it conveniently returns in this order the data sets X train, X test, Y train, Y test. So now, as you've seen, okay, I didn't run random seed. There we go. And I like to print dimensions. You can see 120 by 4, 30 by 4, 120 by 1, 30 by 1. Got it? In general, this is what we're always going to have. Okay, in general, as we're doing in the beginning, at least, our data sets, this is what we're going to have. Any questions so far? All right, good. So if I print the data types, you can see that these are float 64 for the X, and for the Y is int 32. So there are data types involved in deep learning, and this is actually important. There's this concept called sparsity, right? Basically, as the models get really big, this starts to become really important, right? So the size of data types, etc., will hurt you. If you're running on your laptop, it'll start to accumulate a lot of memory, and the things will either run out of memory, will be very slow, etc. That you can also sometimes get little errors and things like that. So as you can see, I'm going to change the data type because we don't need, for this problem, float 64. And so I'm going to change it to float 32. And this is just an example of how you can play with these data types. Some people will go as far as int 8, and things like that, making it very sparse. And that's basically, here it doesn't matter because it's just Iris. But if you were training a GPT, believe me, it's hours of running, and it gets much more complex. It takes quite a bit. Got it? All right. I think I can benchmark a GPT that I run sometimes with about 1,300 samples, and it can take a whole afternoon. And just that's very little. Like, think about it, like 1,000 samples. So imagine if I give it 1,000,000 samples, right? So it's a lot. Anyway, so I'm going to change the data type. So if you notice, all I'm going to do is, this is still happening in NumPy. I'm going to change the data type to float 32. Do you guys see that? So it was float 64 here, and I'm just changing it to float 32. The np.float32 should be an indicator that this is NumPy. So I'm going to go ahead and run that. All right, that should be done. You can print again data type, and it should say float 32 now. Okay, any questions? All right, the next step is pretty important. Should be very exciting to you, as we're going to convert our data into Torch. All right, so we're going to, from NumPy, we need to make it a Torch. So I'm going to go ahead and hit save. And now notice that my X trains, Y trains, X test, Y test have the underscore TR for Torch. And it's just their Torch tensors now. So that's the format. No longer NumPy, and the function is pretty straightforward. Torch dot from NumPy. Any questions on that? Pretty simple. All right, we have to do that. All right, so the next thing is normalization. So if you ever want to get good results on deep learning, you pretty much got to normalize everything. All right, normalization of the inputs is very important. You'll see later on that one of the things that made transformers successful is something called batch normalization or layer normalization. So neural networks just like that. Okay, so think of it as taking any value and putting it in a scale from like -1 to +1, right? In that range. It just, if you're ever having let's say that you're training a model with, some problem, and you're getting bad results, right? The first question you should ask yourself is, did I normalize my data? Did I normalize the layers, right? And if the answer is no, then that's good news, because you should start doing that, and you might start to see that model respond better. You guys see that? All right, so really important. So there's several techniques under normalization. There's a normalization is an actual equation. I generally use standardization, right, which is the one from -1 to +1, and there's the other one I think is from 0 to 1. So this is the one that I will use. This and it's just what I always like to use. Okay, so basically we have our data here. X train TR. So let's think about it. So I'm gonna do here it makes sense to look at the shapes a little bit. So I'm gonna run this one. And then I'm going, yeah. All right, so let's do X train. Remember, this is now a tensor, right? And it's 6:12, so we're gonna take a break in about 8 minutes, but we should be able to finish this script today, okay? So X train TR dot shape. And that's one nice thing about NumPy and PyTorch, that usually they're consistent. There was a time, believe it or not, when they were not. So, but now it's very nice. They, you know, sometimes the same commands. So this is 120 by 4, all right? And now we need to normalize basically all this data. So one other thing that you might want to look at is what the data looks before normalization and what the data looks like after normalization. So, okay, so keep that in mind. All right, so what I'm gonna do now is I need I have 120 samples of flowers, right? Represented as vectors of 4. Sepal width, sepal length, sepal width, petal length, petal width. Those 4 values out of the 120 in the training set, I want to find the mean and the standard deviation of that. And then in an equation that we have available, I want to use that information to transform them basically. Okay, so I'm going to do that now here. If you notice from torch, because this is a torch tensor, I can just give it X train TR and tell it to give me the mean and give me the standard deviation. Okay, and you can just these equations as is. You usually add this little epsilon here. Okay, so now I'm gonna go ahead and run it. There it is, I run it. Now I can run X means and you can see, there it is. It just gave you one vector because it just averaged all 120 vectors into one vector, and that's the mean. Got it? Does that make sense? Any question? Yeah. Pardon? Sorry, I didn't.
Second value,
Keep dimensions. So it's basically keeping the 4 dimensions instead of. So I guess if I did false here, we can take a look. And it does the same, I think. Is a what? It did does it. Oh, it does have an additional dimension. Okay, that's true. That's true. So let me see. So yeah, I guess.
That keeps it in one batch size for dimension. True for false, there's no batch.
Okay. So it's 2 rows containing a thing, is what you're saying. Like if
I mean, size this is.
yeah, that's a good actually that's a really good way of looking at that. All right, so true. X means oh sorry. X means yeah, this is a good way of looking at it. So we're gonna look at it with true. 1 by 4. There you go. So it's 1 by 4. And then I'm going to do false here. Yeah. So this is going to become important with when we start doing operations where we have all, you know, the several you know, we have several rows for the data set, and so on. So that's, it's useful for that. So we're gonna keep it as true. And then it gives us an array that is 1 by 4, a matrix, basically 1 by 4, okay? All right, and the same over here. Pardon? No, it just means that there's 4 things in there. So it's a vector of 4. So if I do false, it's just 4. It's not, I would say it's just a vector of 4, whereas with the other approach is 1 by 4. So it's a matrix. Because you could have 2 by 4, right? Or 4 or 3 by 4. So it's a matrix. It's a, think of it as a 2-dimensional array or a 1-dimensional. This is actually really important. The best thing that I can tell you is that sometimes this is important because if you sometimes do operations and you give it this, it's gonna break. But if you do, because it's only 4. So if it's true, and it's 1 by 4, then it wouldn't break in the operation, okay? So this is related to something called squeeze and unsqueeze, and sometimes we will have to do that as well, so that something that is 4 becomes 1 by 4, and that just has to do with sometimes the operations that we do are more similar to linear algebra, so they need to have specific dimensions of how it treats things, okay? So, but yeah, how the operation is applied. So this is a common thing that we'll encounter. All right, so yeah, that was a good way of looking at it. So we keep it as true, and now we have that it is a 1 by 4, you know, I guess, yeah, a batch of 4 items in there, but a matrix, I would say, of 1 by 4. All right, if we look at the data itself, we have 4 values, and these should be the means of the 120 values in the train set. So for column 1, the mean of column 1, for column 2, the mean of column 2, for column 3, the mean of column 3, and for column 4, the mean of column 4. So we've found the mean of it, and that's the operation that we're going to do. We're going to adjust all the rows based on these means, and that's normalization, okay? So there's an equation that we're going to follow for this, and we'll cover that later on in the script. So here I'm just generating the x means. There's the shape, and then x deviations should be the standard deviations. So that also has 4 values, and the shapes is again 1 by 4, okay? So yeah, so we're gonna, it's basically like take whatever the value is, and I don't remember exactly, but it's like times this minus the standard deviation or something. We'll take a look at it in a bit. All right, so that this is something that you're going to be doing, right? Creating the x means and the standard deviations. All right, so notice that I'm not using them yet, okay? So I've just created them, and we're gonna use them a little bit later in our processing, all right? But this is a concept that is really important. It's something that will be used throughout the semester in every single algorithm, and it always provides really good results, okay? All right, so the next thing that we're gonna cover is the data loader. So it's 6:20, so this is a good stopping point, okay? So I'm going to stop this video. We're going to take a 10-minute break, and then we will come back and continue until the end of this script. All right. And remember, this is your first neural network. Okay. All right, guys. So I'm going to stop sharing. I'll end this video. Let's come back at 6:31.